Our first order of business is to create the tank, which is going to be our player. Our player tank will consist of 3 nodes in its hierarchy. Because this is a game and it's not really based on reality, we're going to organize its hierarchy like this. The top node is the player's root transform. We only need to translate this node and not rotate it. The chassis, or the body of the tank, is directly below that. It's only going to be allowed to rotate on the y-axis. Because this is a top-down game and we don't really visually register the other axes, there's no point in rotating in either X or Z. The turret is also directly below the top node of the player. And remember, this isn't based on reality. This is just convenience to program its behavior. The turret, like the chassis, will only rotate in Y. And the gun is going to be part of the turret. We're keeping things simple here, so it's all just one piece. Let me add a floor object so we can give our player somewhere to stand. Floor prototype 64 by 1 by 64 should do the trick. Bring it in, and I'll just make sure that it's not transformed at world origin. Now we can bring in the geometry for our tank, and we'll get that from the resources. If you download that, the tank should come in as 2 pieces. Download it, unzip it, and then bring in the tank chassis and the tank turret as new assets. You should see a tank chassis and a tank turret model now in your project. Once we've imported them, we'll make a models folder, and we'll put both of those geometries into the models folder. In the hierarchy window, make an empty object and make sure its transforms are reset. I'll rename it player. To the player object, add a rigid body component. Under the rigid body's constraints, check freeze position in the y-axis and freeze rotations for all of the axes. The player transform is only going to move in the X and Z direction, and it's never going to rotate. Select the player node and then create 2 other empty nodes as child transforms. And make sure they come in without any values on the transforms. And you can rename these nodes to chassis and turret. Bring in the turret and chassis models and place them underneath of the individual transforms. Just for bookkeeping, I renamed the geometry nodes to turret mesh and chassis mesh. You don't really have to do that. And the animator components I don't really need. They came in from the FBXs, so I can get rid of those. Now the geometry is modeled so it comes in at the correct place without any transforms. But if you do decide to use your own model for whatever reason, then you should be able to shift the chassis mesh or turret mesh nodes as you need to. We're only going to be rotating the parent nodes, the chassis or the turret, not the mesh nodes. And note that we're not parenting the turret to the chassis like it would be in real life. Our player tank will move with a script, and we need our chassis and turret to move independently of each other. If I made the turret a child of the chassis, like it would be naturally, it would just be another transform I would have to undo as I calculated the turret rotation. So to keep things simple, they're both directly underneath of the root node. Let's add a capsule collider to the root node of the player. We're going to make the collider relatively large because the turret has this long barrel, and it could look like it's bumping into things if I'm not careful. Now I could do something complicated and make some script to make sure that the barrel never intersects any walls or vertical surfaces, but I'm going for the simpler solution, and I'm just going to make a big collider so we can't actually move the tank too close to walls and make awkward intersections with the barrel of the gun. I'm not quite sure on my values, so right now I'm going to increase my collider radius to 2, and I'm probably shifting the center of the collider up by 1 unit in Y. The collider is slightly embedded in the ground, and normally that would be weird, but in our case the tank won't be allowed to move up in Y, so we should be okay doing this. So I think I am going to settle with the center at Y equals 1, And just to verify that, let me test how our collider behaves against a simulated wall. Let me bring in a block from the prototyping assets just to test it. So we're not really going to drive our tank, but imagine if your collider were pressed against this wall, then you could swing the turret to see how bad the intersection is. That's not terrible, but I'm probably going to modify the model a little bit more. By the time that you get this tank model, it might be a little bit different than what you see here in the video. So don't be alarmed if your tank geometry is a little different than what you see here. I could take some artistic license and really shorten the gun barrel, but I don't want it to look too cartoony. So it's just going to jut out a little bit, and that's a creative choice. So once I think we've settled on our collider size, you can delete the wall geometry that we brought in for testing. Now, it'll take a while to get here, but here is an early demo of our tank player controls when it's mostly complete. Though it's not physically accurate, the tank basically does what we want it to do. The chassis and the turret can move independently of each other. Now, our controls to drive the tank will consist of using the keyboard and mouse input. You'll be able to control the translational movement with the keyboard. If you use the arrow keys or the ASWD keys to move, the chassis will turn toward the direction of input, and then your player will move forward, always toward the chassis front. The turret will always face the mouse pointer, so when you click the mouse button, the gun will fire. Now you can fire a volley of shots or a single shot depending on how we configure the tank. Okay, it's going to be a little bit before we get to this point, but to make our tank drive, we're going to need a script, and we'll create a player motor C# script in the next lesson.